Hi everyone, I'm DJ Schleen. I'm a Senior Manager of Application Security at Rally Health. I'm really excited to be here today at SnykCon 2020 to talk a little bit about some of the ideas and some of the things that I've been doing over the past few months since I joined Rally Health. This presentation is called Blow Up Your Security, and I hope you enjoy it. No matter if you're a small organization starting your journey towards adopting DevSecOps practices, or you're a large organization with existing programs in place to address application security, one of the things that's critical is having visibility into your applications, your source code, and the languages that your engineering team uses to develop software. That's one of the things that I did when I came into the role of a Senior Manager of Application Security. I wanted to leverage the existing programs that were in place and have an ability to take a more engineering-centric approach to application security. Now, some of the concerns that the application security program I wanted to put in place addressed were mainly three separate categories, and of course some periphery of concepts and concerns that any application security team is going to have to address. The first pillar of concern is called analyzers, and what I wanted to do was find out how our configurations for our applications stood up from a security perspective. Were we exposing secrets? Were we injecting them into our products the right way? That kind of thing. I wanted to take a look at our application security vulnerabilities and enhance those programs to take a look at what kind of vulnerabilities that we had and what kind of third-party components we were using in our application, and get a handle on that and see what vulnerabilities that we actually had out in the field at the time. Infrastructure is another concern, and as we start moving towards more of an infrastructure as code mentality in our engineering organizations, we really need to take a look at our engineering infrastructure. Is our infrastructure configured properly? Are we encrypting things? Are we injecting secrets into those open source or source readable application pieces of code? Validation is another concern that I wanted to take a look at, which is when we validate our policies and things that we have defined at a governance, risk, and compliance level in our security organization. So are we encrypting S3 buckets? Are we utilizing the proper password strength in our applications? So validation is a big part of that. We want to be able to ensure that the policies that we put in place actually hit the code and are implemented in the code that goes out the door. Penetration testing is another part of that validation, where we're looking at the application from an external view and seeing what we can find that possibly our automated tool sets can't. So this is looking at ways around authentication systems, etc. Observation is the number one thing that I needed to address. Is what were we having show up in our logs? What kind of policies were we running, and how many were passing, how many failing, and the visibility for the vulnerabilities we have, and how do we address and triage these? And of course, the periphery, which is the educational aspects of software security, training and teaching our engineers and helping them learn software best practices for software, secure software development, and how to manage secrets, as well as to overly simplify as much as we could any of the security programs that we were putting in place from an application security perspective. And that's just what engineers are looking for, is that simplistic approach to application security. Now, don't get me wrong, there are security tools that were in place when I joined the organization. They just weren't visible on an enterprise level. Application security is definitely taken seriously by a lot of engineers. And I think as a software security organization, sometimes we don't give enough credit to the engineers that they are actually trying to secure their code as they start learning about these concepts. That's where education really comes into play. So what we wanted to do, and this is an overview of the action plan that was put together, was we wanted to solve security problems with engineering effort. We want to answer questions with an engineering mindset. How do we integrate security into our pipelines with little to no business impact? We want to make sure that all the application flows out to production as fast as possible and with as much security baked in as we can. We don't want to interrupt the value that's being delivered to our customers. The second thing that we wanted to ask ourselves was, how do we automate the verification and analysis and vulnerability management in a way that we could maintain it with a smaller team and more effectively change it as we learn more about the process and learn more about the impact of our security tools on our automated processes. And the third thing we wanted to do is see how we could disseminate that information, the things that we got from the observability, and who could get the information, or who should get the information, and what frequency they should get it, and is it relevant to their concern or to their domain of expertise or their organizational unit. So the truth that we found after looking at a lot of ways for implementing security tooling into our automated pipelines, and some of the lessons learned from implementations in the past that I've been a part of, is that security is really addressed best when it happens before a merge happens in a commit. So when a developer is committing code and creating a pull request to have their changes merged into their main branch, that the security scanning and verification is happening in that step before the code even gets into the main branch of a repository. So this is one of the things that we came up with, which is triggering some of these checks as code gets merged in or before code gets merged in. So the first thing we want to do is verify that the new changes don't violate any organizational policies that we have in place. And these are the coded policies. So policy is code that we've defined that get applied to the code when it gets checked in and put into a pull request. And we validate that these changes don't violate those policies. So for example, we are looking again at those encryption keys or encryption flags on an S3 bucket. We want to make sure secrets don't exist inside of our code base. These are the kind of checks that we're looking for when we want to verify the code. The second thing we want to do is analyze the code inside of that pull request. So we're going to look at things like software composition analysis, look for open source software that's in our systems, and look at the vulnerabilities that exist in those components. And then we can act on those in certain ways. We can create pull requests that come out that remediate those issues. We can deal with them right then and there inside of the pull request and remediate them. Or we can look at creating a JIRA ticket, for example, and remediating those at a later date and prioritizing them in our backlog. We can look at static analysis and security testing in this analysis phase, which is looking at the software security issues and vulnerability issues in the code that we do create in our environments and in our organization. We can also look at different non-security related functions. So is the build succeeding? Are our unit cases, our unit test cases passing? These are the kind of things that we can do inside of this pull request. And the third thing we want to look at is simplifying things. So after we look at the validation of policy and the analysis of code, we can have discussions inside that pull request and have a log of the remediation and the fixing and the justification for fixing or not fixing inside of that pull request itself. And the nice thing about that is it's a documentation effort. What we're doing here is we are addressing security issues before the code gets into the merge and gets merged into our main line of code. And that causes some interesting conversations. So think about an automobile manufacturing assembly line. If something happens to your airbags in your car as you install them on the assembly line, and there's a problem, the assembly line can get stopped and the issue gets remediated right away. But there's not a ticket or a work order that gets created to remediate that. It's a scramble, people fix it, and things move on. And so that's like looking at an application as it's being assembled inside of a build pipeline. Do we create a JIRA ticket or a work item just because something's happening before the application gets merged or the code gets merged into our main line? Well, the answer is no. It's a discussion point. You wouldn't create a build ticket or something like that to remediate a build breakage. You'd fix it before it gets merged into the main line. We have to treat security in the same way as engineers treat the code, and the vulnerabilities or the bugs that exist and that potentially break builds at that pull request time. So reworking the changes on the assembly line in the automobile manufacturing plant, when that car gets out of the building is when we start the warranty process. And then we create service tickets and work orders and that kind of thing to remediate defects in our manufacturing process in the car. And that's the same kind of thing. After the code gets merged into our main code line in our source code repository, that's when we want to address those issues and ensure that we have something to track that work. So one of the big myths that I think is that security always breaks the build, right? And it can. So one of the mistakes a lot of people who are adopting automated security programs and practices and starting to integrate these things into their automated pipelines and their automation techniques is they will set up these tools to break the build. And the problem with that is a lot of security issues can't necessarily be remediated right away. So for example, you might have a vulnerability in a piece of code that's an open source component. You might have a newer, cleaner component that you could go to and have that fixed inside of that pull request process. But what happens if you have no remediation for that? Maybe the component's not supported anymore. Maybe there is no new version yet. So then what do you do? And that's goes into the fact of this is like mistakes break builds, and that's what pull requests are for. So if we can't do things like that, we need to have a solution to have an exception to let the build continue. And that's where security engineering really comes into play, where application security engineers need to think like software engineers and come up with a solution that keeps the flow going on that assembly line of product. So this is a solution that we came up with to start introducing some of these concepts such as infrastructure as code validation, policy as code, and policy checking, and integrating some of our other traditional security tools like software composition analysis and static analysis and security testing into our pull request process. And this is, again, the perfect place to put it because we're dealing with an atomic code change, and we can do things in either an incremental way, or we have the control of scanning things on a holistic way on the whole entire application. So here we have a check that's set in place. And if there is a break, we can have right here an exception request that triggers an exception conversation and an exception flow that can make it back to our governance, risk, and compliance tools so that we can track that a security exception exists or security vulnerability exists. And then how do we action the remediation of that issue later on and create a JIRA ticket or something like that for it. Again, that addresses some of these concerns that we might not be able to fix something immediately in the pipeline. So we don't want to halt the product development and the value being delivered. And so a little bit deeper look into what's happening in this stage. This is a GitHub application, so we can deploy it across all of our application repositories. So this is the importance of knowing what you have out there and what languages you have out there, so that when we put something across our GitHub organization, we don't really care if it's inner source, if it's outer source, or if it's piece of test code. No matter what it is, we're scanning it for vulnerabilities. We can get an exception to the checks for infrastructure code that's more of a tooling that we use for our automation. But from the code perspective itself, we can look at things like Terraform CI, where we're doing an application plan. We're ensuring that the Terraform code check-in conforms to specific application policies or security policies that we put in place. We can look at our security scan for other policies that we want to have in place. So our Kubernetes configuration, secret management, you name it. Because the policies are as code, we can apply whatever we can imagine to link a check in a automated way all the way back to our GRC tools that actually define these compliance standards and governance and these control standards. So, HIPAA, NIST, 853, SOC 2, whatever compliance requirements that we have, we can take those all the way down to the code level, and then we can version that code. We have the attestation that our policies are actually being utilized and enforced. And then we can run our other tools. So here we have our software composition analysis being run. The nice thing about this is all of that information is coming out of this pull request in that scan for any of the languages that we support and coming right back into our centralized system where we can monitor and actually execute pull requests centrally on the application security team. So everything is combined into one step that goes all across our code base in our GitHub organization, which is fantastic because it allows us to quickly react to change ourselves on the security engineering side. And the same approach works with, again, other security scanning tools. You can even use this to integrate to any other tool. And this happens at that pull request. So whatever you do to package your application and whatever CI/CD tool you want to use, you know that by the time the code gets in and you start actioning all these additional processes to get the application to your staging or your delivery into green or blue environments, that security has already been taken into consideration. You can do additional checks, but you know that your code at the point where the scan was made has been clean. And this allows us from that centralized location to get our observation criteria in place. So we can throw information to the security operations center. So our software bill of materials, what we're utilizing in our software. We can send information and feedback back to the engineers by putting the scan results and that information back into the pull request so those discussions can happen. Our product owners can get visibility in things that can't be remediated instantly and have that they can groom into their backlogs. Audit gets satisfied because we have proof that our code is being scanned and policies are being enforced in our application code. Executives and stakeholders can get information such as how many individual vulnerabilities do we have? So do we have 6,000 high vulnerabilities, 500 mediums? How is that trending down? We can start calculating a lot of this information. Application security, we can get that information and centrally aggregate it and then do really cool things such as having a scorecard bot that sits in Slack where any executive can type in a scorecard name for themselves or for anybody on their team and find active KPIs right up to the minute, if not 15-minute delayed. But this is things that we're doing with some of this data coming out of these systems, is getting information to our executives just as fast as we'd expect it to our developers. So we're shifting everywhere. We can make business decisions on application security quicker rather than at a delayed rate. And of course, the governance, risk, and compliance aspects of this is tying that information and those policies that we gather in a security organization and actually have irrefutable proof that they are being exercised, and we're looking for validation that things are not violating those policies as we check in the code. So a few things, for us to enable engineers is we want to know how our engineers work, and we want to work like them. We want to make sure that as an application security organization that we're implementing processes that engineers understand, that we're working side by side with engineers, and we're solving security problems the same way that they are. We want to translate our governance and compliance and put that into engineering speak. We have these high-level abstract concepts in our compliance and governance and the regulations that we have to adhere to that we need to break down and distill into developer speak. This is what the problem is. This is the cause of it. And here's remediation steps to deal with this issue. All at the same time, we want to minimize the interruption and the integration points as we start automating these processes. And that's why we went with this pull request approach, where we tackle a lot of security concerns in one place. The impact is mitigated because we can track how long each one of these tools operates inside of our commit hooks on the pull requests. So we can actually see how long our tools are taking, and then we can also go in and iterate on improving the scan times for ourselves, because we want to make sure, again, that security tools, just like any other tool that we would use, don't interrupt the flow of product to our customers. And the entire idea, summarizing it to one line, would be catch the fish before it reaches the ocean. We want to catch security defects as far left as we can, similar to how in DevOps we're catching bugs and issues as far left as we can. This is the true essence of DevSecOps, and this is what we're looking for. So imagine if you ran your application security team like engineers that know a lot about security, rather than a security team that knows little about engineering. Now, how would that be? What would that mean to you as an organization? Well, that's how you enable engineers, and that's how we enable DevSecOps. So I appreciate your time today. That's Blow Up Your Security, and we're all engineers. So I'm DJ Schleen signing off from SnykCon 2020. I hope you enjoy the conference, and we'll talk soon.